Alright, hey guys. So today we're going to be talking about percent dissociation and percent ionization. So percent dissociation, just to make it clear in the beginning, percent dissociation deals with the weak acids and percent ionization deals with the weak bases, which is why I have the white arrows drawn out towards the specific reaction. Now, if you watch the previous two videos about the weak acid and weak base dissociations and how to find the pH based off of that, you'll find these ice tables and you'll find these concentrations very, very familiar. Okay, and this is basically the process that we use in order to find our end molarities when the reaction of a weak acid or a weak base reaches equilibrium. Now, the reason that they might ask you for percent dissociation or percent ionization is because we know that weak acids and weak bases don't dissociate 100%. We know that strong acids and strong bases do, but not weak acids and weak bases. What this means is that at equilibrium, or at the end of the reaction, there'll still be some weak acid and still be some weak base that remains, okay? And that's not the case when it comes to strong acids or strong bases. So that's why they'll ask you, what percent did this weak acid dissociate? To what percent did this weak acid dissociate to? To what percent did this weak base ionize to? Okay, so that's exactly what we're going to find in this problem. So here, we have to understand that the equation we use when it comes to percent dissociation is the amount that dissociates, so the amount that dissociates over the amount that you have initially. And sorry for the abbreviations, we're just lacking a little bit of space, but the dis stands for dissociation and the int stands for what you have initially. So the amount you have that dissociated and the amount that you have initially times 100 to get a percent. Okay, and that will give you your percent dissociation. So how do you find the percent that dissociates? Well, that's simply your H plus concentration at the end of the reaction. This is the amount, this is the concentration of H plus that was produced from this weak acid. So this is the amount that dissociated from the weak acid. This 0.01 moles per liter is the amount that dissociated from the H and O2. In order to produce H plus ions and NO2 minus ions. So if we were to find the percent dissociation of this problem, okay, the problem of HNO2 dissociating into H plus ions and NO2 minus ions, we would do the ice table and we would find our end concentration for H plus, and we would divide this number because this H plus concentration is the amount that is dissociated. It's the amount of H plus ions that was dissociated from this weak acid. And I know I said that a lot, but that's a very, very important concept. So this H plus concentration is going to be the amount that was dissociated from the weak acid. So it'll be in our numerator. And in our denominator, we'll put 0.250. And that's because that was our initial concentration of weak acid. That's what we had initially at the beginning of our reaction. Okay, and if we were to multiply this by 100, we would get a percent of 4.00%. This percent is our percent dissociation. That means that 4% of our weak acid has dissociated into our H plus ions and into our NO2 minus. Okay, so that's going to be our percent dissociation. The same concept applies with our weak bases, except it's named differently. It's called percent ionization. We take whatever OH minus that we've produced from this dissociation of NH3, or from this ionization of our weak base. And so we take the amount that we have at the end of the reaction, the concentration of OH minus that we have at the end of the reaction, and compare it to what we had initially, which was 0.1. We had 0.1 moles per liter of ammonia. And we have to multiply this by 100. And if we multiply it by 100, we should get 1.3%. Okay, 1.3%. This 1.3% tells us that this NH3, this ammonia, had a 1.3% ionization to create a certain amount of OH minus. So this NH3 dissociated to or ionized to 1.3%. Excuse me, I'm getting kind of mixed up. So bases, ionization. So this weak base ionized to 1.3%, while this weak acid dissociated 4%. And it's pretty much the same thing, same formula really, but they're just different names. Bases are ionization and acids are dissociation. I hope this video helps, and I hope you tune in for more. Thank you.